Okay, this is practice problem 3.21. So, adipic acid is used to produce nylon, which is made commercially by a reaction between cyclohexane and oxygen. Okay, and you're given the balanced chemical equation. So assume that you carry out this reaction with 25.0 grams of cyclohexane, okay, which is the C6H12, and that cyclohexane is the limiting reactant. Right? So what is the theoretical yield of adipic acid? Okay, well, if we're given grams of C6H12, right, we're given 25 grams, and we want to figure out what's the theoretical yield of adipic acid, then we need grams of, we'll call it AA, okay? Well, same as like the last few problems we've done, we need to first convert to moles of C6H12, and then we can convert that to moles of AA, to grams of AA. Okay, and so if we're starting with 25.0 grams of C6H12, we first need to convert that to moles of C6H12, and we can divide that by the molecular weight. For C6H12, this is going to be 84 grams. Okay, then we can convert the moles of C6H12, which there are 2 moles of C6H12 for every 2 moles of adipic acid. Right, and so we can get this number from this 2 and that 2. Okay, and then we're multiplying that for 1 mole of AA. There is molecular weight, which is 146 grams. Our moles are all going to cancel, so we're left with grams of AA, and what we find is that we have 43.5 grams of adipic acid. Okay, and so that's our answer for part A. Part B asks what is the percent yield for, then it asks for what is the theoretical yield. Or, we calculated that, right? This is our theoretical yield, call that TY. We're looking for the percent yield now, okay? So in part B, we are looking for percent yield, which is just equal to the actual yield divided by the theoretical yield times 100. Okay, and so we're told that our actual yield is 33.5 grams, and we're dividing that by our theoretical yield, which is 43.5 grams, times 100, gives us a total of 77.0%.